Hello students, welcome to EPG Pathshala. I am Dr. Anupama, Professor at Department of Economics, Punjabi University, Patiala. I am here talking on behalf of Dr. Falendra Kumar Sudan, Professor, Department of Economics, University of Jammu. I am going to talk about the module Implications of Population Growth and Urbanization for Climate Change from Demography of Climate Adaptation. So students, we are going to discuss about the production and consumption perspectives of population growth, urbanization, and climate change. Almost all population growth in the foreseeable future is likely to take place in urban areas, mostly in developing countries. There are several multiplicative factors involved in the linkages between urban population growth and carbon emissions. All these factors vary significantly among population subgroups within countries, across countries, and over time. Urban centers are not only hosting a growing proportion of the population and economic activities causing climate change, but they also adapt to the consequences of climate change. So, the present module aims to understand how the population growth will evolve in the face of fast-paced urbanization in the context of climate change, and to analyze how the production and consumption dynamics of urbanization is linked to population growth and emissions. Drivers of growing greenhouse gas emissions in urban population. Much of the growth in the world population is occurring in urban areas of low and middle income countries. This is likely to continue in near future. How the growth in the world population influences greenhouse gas emissions. How the growth in the urban population in low and middle income countries influences greenhouse gas emissions. The contribution of urbanization to climate change can be assessed production perspective, where GHGs are produced, or from the consumption perspective, that is the GHG emissions due to consumption and waste generation by urban populations. The most probable sources of growing GHG emissions in urban population from these two perspectives are the sectors of energy supply, industry, transport, residential buildings, and management of solid waste and waste water. Now we can discuss about the production perspective. The greenhouse gases are produced by number one, energy sector, largely from fossil fuel power stations, resulting in a growth in electricity provision from high GHG emitting sources. The industry, that is due to growing level of production, growing energy intensity in production, increasing importance of industries producing goods, and the fabrication of which entails large GHG emissions. The third one is the transport sector. The growing use of private automobiles increases in average fuel consumption of private automobiles, and the increased air travel add to the GHG emissions. The residential and commercial buildings, the growth in use of fossil fuels, and growth in electricity use from fossil fuels for space heating and cooling, lighting, and domestic appliances all add to the GHG emissions. The waste and wastewater, the growing volumes of solid and liquid waste and more energy intensive waste also add to these emissions. On the other hand, from the consumption perspective, the greenhouse gas emissions grow in urban population in many ways. The energy sector, the GHG from energy supply or electricity generation now assigned to consumers, so the GHG growth is driven by increasing energy use. The industry, the GHG from industries to the final consumers of the products. Number 3, the transport, the GHG emissions from fuel use by people traveling outside the urban areas in which they live are allocated to them, and GHG emissions arising from investment in transport infrastructure, residential and commercial buildings. Addition of GHG emissions arising from construction and building maintenance, the waste and wastewater, large and often growing volumes of solid and liquid assets which contribute to GHGs these are allocated to the consumers who generate the waste, not to the waste or waste dump. All the drivers of the growing GHG emissions can occur in a national urban population or in a particular city not experiencing population growth. This is especially the case if the consumption perspective is adopted. The Greater London's population, for example, was larger in 1941 than today's population, but the total GHG emissions generated by its population's consumption are likely to have increased many times. As far as production perspective is concerned, if energy-intensive production is concentrated in cities, their average GHG emissions per person will increase unless the production is served by electricity not generated from fossil fuels. This can imply that particular cities in low and middle income nations with heavy industry or fossil fueled power stations can have very high carbon dioxide emissions per person. The real issue is the inappropriateness of allocating responsibility for greenhouse gas emissions to a nation as a whole and by implication to that nation's entire population or to urban areas in general or to particular cities and by implication to all the urban population or to population of particular cities. The human-induced greenhouse gas emissions are not caused generally by people, but by specific human activities, by particular people or group of people. Generally, it is not urban populations that account for using high private automobile or high levels of air travel or high consumption lifestyles, but particular individuals or households. Any individual and household can contribute to global warming when they consume the goods and services that generate greenhouse gas emissions. Therefore, the fundamental cause of global warming is the consumption of goods and services that draw on resources for their fabrication, distribution, sale, and use, resulting in the emission of greenhouse gases. But at the same time, considerations should also be given to the production systems that solve this and encourage high consumption. Urban population and greenhouse gas emissions, some evidences. Due to the low income levels, if family members in urban households are severely undernourished and can afford only one meal a day, it is not likely that their consumption patterns are generating much GHGs. Further, it is also likely that they may use fuels largely or completely based on renewable resources, which means no net contribution to GHG emissions. In a study covering 44 nations, 17 had more than half of their urban populations, depending primarily on non-fossil fuel for cooking. There were also 11 nations where more than half of urban households did not have access to electricity. But even when low-income households shift to fossil fuel-based energy sources, usually kerosene in low-income nations, their consumption levels remain low. In Delhi, low-income households that depend on kerosene typically use 25 to 30 liters per month, which implies the carbon dioxide emissions per person per year of around 0.15 to 0.2 tons, very small by global standards. Low-income urban households also use transport modes that produce no GHG emissions, that is, through walking or bicycling, or low GHG emissions, that is, by using buses, minibuses, and trains, mostly used by more than full capacity. Even when urban dwellers do obtain electricity, the consumption levels are often very low. For instance, in low-income households in 3 Indian cities, just 32 to 33 kilowatt hours per month were used. A very significant number of people may have zero or negative GHG emissions per person. Among these, there are many low-income urban dwellers whose livelihoods are based on reclaiming and reusing or recycling waste. The GHG emission saved from their work equals or exceeds the GHG emissions that their consumption causes. It may also include tens of millions of small farmers able and willing to engage in sustainable agriculture and in maintaining or increasing forests on their land. Therefore, up to 1/6 of the world's population has incomes and consumption levels that are so low that they are best not included in allocations of responsibility for GHG emissions. The failure of more than 50 years of development to reduce the number of people living in poverty reveals that a very significant share of the total population in world will continue to live in extreme poverty and in effect contribute very little to further GHG emissions. However, changes in income distribution within urban populations have great implications for GHG emissions in future. For example, in households in Mumbai with an income of 1,50,000 rupees a month is likely to contribute far more GHG emissions than a pavement dweller household. Therefore, the frequently used formula of I is equal to P into A into T, that is, the impact relating to population, affluence, and technology, should be changed to I is equal to C into A into T when applied to global warming impacts, where C being the number of consumers, not the number of people. Moreover, it is neither fair nor correct to propose that either population growth or urbanization essentially causes increases in GHGs. This increase relies more on the form and levels of consumption among the growing population or among the population that moves to urban areas. For instance, various urban centers in sub-Saharan Africa and low-income nations in Asia, including many with growing populations, tend to have very low average GHG emissions per person, whether from the production perspective, because they have very little or no industry and most of the population has very low fossil fuel use within households or for transport, or from the consumption perspective, because with a very low proportion or no residents with high consumption lifestyles. This is not acknowledged, partly because there is non-availability of data on their emissions. However, it should also be noted that many nations whose average annual per capita carbon dioxide emissions are below 0.2 tons, that is less than 1/200th that of United States or Canada.
In 2005, 13 nations had average carbon dioxide emissions per person less than 0.1 tons. In comparison to this, there are nations where in recent decades, with slow or no population growth and very small increases in level of urbanization, both GHG emissions and GHG emissions per person have increased rapidly. This would be especially the case when there are statistics for GHG emissions from a consumption perspective. Furthermore, it is unjust to equate increase in GHG emissions per person among low-income populations, for example, from 0.1 to 0.5 tons of carbon dioxide emissions per person per year, with comparable GHG increases among high-income populations, for instance, from 7.1 to 7.5 tons per person per year.
The reduction in global emissions is required to avoid dangerous climate change. It will depend on achieving a particular global average for emissions per person. It is sometimes termed as the fair share level, generally set at around 2 tons of carbon dioxide emissions per person. The making provision for increases in the greenhouse gas emissions for those people below the fair share level so that they can move out of what might be termed energy poverty cannot be taken into account in the same way as increases in the emissions for those already above the fair share level. In case if all of the above arguments are accepted, then the relation between population and climate change, and within this, the links between urbanization and climate change is altered. The increases in greenhouse gas emissions per person by people living below the global fair share level should be treated differently from increases by people above it. The majority of the nations with the most rapid growth in their national and urban populations account average greenhouse gas emissions per person far below the fair share level.
Urban population growth and growth in greenhouse gas emissions. There is evidence that the rapidly growing urban population have very low level of carbon dioxide emissions per person and experienced slow growth in these emissions. Many nations with the slowest growing urban population have the highest level of GHG emissions per person and have had a rapid growth in carbon dioxide emissions per person. Between 1980 and 2005, some high-income nations had a slow growth in carbon dioxide emissions per person because they already had very high per capita emissions. If data were available for the consumption perspective, it is likely that high-income nations have had a much greater growth in emissions per capita, and many low and middle income nations have had much less growth in emissions per capita. The data for average carbon dioxide emissions per person is available for 1980 and 2005 in 185 nations. These can be divided into 5 sets of 37 nations each. Among 37 nations with the highest carbon dioxide emissions per person in 2005, 10 were high-income nations encompassing North America and much of Europe. 3 small populations, high-income Middle East oil producers, and the highest emissions, that is Kuwait, Qatar, and United Arab Emirates, and very high population growth rates, mostly from immigration. However, in general, this group of high emissions nations had very low population growth rates between 1980 and 2005. More than half had average population growth rates of less than 1% a year for this period. Out of the 37 nations having lowest carbon dioxide emissions per person, all were low-income nations, and 29 were in sub-Saharan Africa. 34 had population growth rates of more than 2% a year, and 9 had population growth rates of more than 3% a year. Thus, considering change in carbon dioxide emissions per person linked with population growth for the period 1980 to 2005, many of the nations have the slowest population growth rates, and many had the fastest growth rates in carbon dioxide emissions. Generally, high income or upper middle income nations are the countries with low population growth and high carbon dioxide emissions growth. These are mostly in Europe or Asia and all had very significant economic success in the period 1980 to 2005. The high population growth with low emissions growth are mostly low-income nations, mostly in sub-Saharan Africa, and many had little economic success during this period. Thus, economic development has considerable impact on carbon dioxide emissions. In China, the rapid growth in production from 1980 to 2005 contributed significantly to rapid growth in carbon dioxide emissions. This is also experienced in South Korea and Thailand.
Therefore, population growth can only be a significant contributor to greenhouse gas emissions if the populations that make up this growth have levels of consumption that contribute to significant levels of greenhouse gas emissions per person. Or, from the production perspective, live in nations with a rapid increase in greenhouse gas generating production. Of course, this is relevant not only for now but also for the future in the lifetime contribution to greenhouse gas emissions of people born today. If major proportion of the growth in the world's population is among low-income households in low-income nations who never get out of poverty, then there is and will be little association between population growth and green gas houses emissions growth. But even if a significant proportion of the future increases in GHG emissions is from nations with rapid population growth, if the increase is below the fair share level for average per capita emissions, it cannot be judged as comparable to that in the nations above that level.
Moreover, a growth in GHG emissions per capita among those individuals or households below the fair share level should be taken into account as qualitatively different from any growth in GHG emissions per capita among individuals or households above the fair share level. It is essential to give more attention to changes in production and consumption within nations for identifying the major potential contributor to GHG emissions growth in the future. For any consideration of GHG emissions and population, it is essential to consider each nation's changes in production, consumption, income, and distribution. This is, of course, associated with urbanization. Urbanization and climate change. Urbanization is often held responsible for climate change. Around the world, cities account for 80% of all GHG emissions. However, in reality, only about 35% of global GHGs are emitted within city boundaries. Urbanization brings higher GHG emissions. The per capita emissions in urban areas are higher than those in rural areas because of the big differences in productive and consumptive behaviors, between rural and urban populations. Certainly, this is not always the case. In many nations, a large proportion of high income and high consumption households live in rural areas and are likely to have higher average GHG emissions per person or per household than urban dwellers with comparable incomes. This is because of larger, less energy efficient home and the greater use of private automobiles in rural areas. This is partly because New York, London, and Barcelona have much lower average GHG emissions per person than the national average of the United States, United Kingdom, or Spain, respectively. The population growth in the next few decades is expected to be in urban areas in low and middle income nations. The relation between population growth and GHG emissions will be influenced by the GHG emissions implications of urbanization in these countries. Urbanization can be considered as the major contributor of climate change. Generally, the more urbanized a nation, the higher the GHG emissions per person. But at the same time, it can also be viewed as a key part of the solution as it offers the basis for delinking high standards of living, quality of life, from high GHG emissions per person. There are very large differences in per capita emissions among cities. For example, Barcelona is generally considered a city with a high quality of life. New York City has 1/3 to 1/2 of GHG emissions per person in cities of United States. Many of the most desirable and expensive residential areas can be made very energy efficient. The settlement patterns and public transport system allow most trips to be made on foot, bicycle, or on public transport. In fact, one of the drivers of urbanization possibly is the economic advantages that closely provides for a large variety of enterprises. Regarding the impacts of climate change, cities constitute the most serious problems as they concentrate people and their assets, industries, and infrastructure in ways that increase risk and vulnerability. Many cities and smaller urban centers are in locations that are particularly hazardous due to climate change. Urban areas also have great potential advantages in building resilience to climate change impacts. The urbanization level of selected nations plotted against per capita GHG emissions for 2005 in production perspective is shown in figure 1. In this figure, the small blue diamonds represent low-income nations, the small white diamonds lower middle-income nations, the black triangles upper middle-income nations, and a large blue squares high-income nations. These figures include not only carbon dioxide but also the other greenhouse gases included in Kyoto Protocol, and their contributions to global warming are converted into carbon dioxide emissions. Generally, the more urbanized the nation, the higher the GHG emission per person, though with considerable variations in emissions level per person for nations with comparable urbanization levels. The wealthier the nation, the higher is the GHG emissions per capita. The majority of the low-income nations have less than half of their population in urban areas. Many have per capita GHG emissions below 0.2 tons a year, and very few have 2 tons a year. Obviously, part of the large variations in GHG emissions per capita between nations with comparable level of urbanization may be explained by the different criteria used to define urban populations or urban places. However, It should be noted that upper middle and high income nations and many of the lower middle income nations had GHG emissions per person above the fair share level, with the United States and Canada having more than 10 times that level. Is urbanization a driver of climate change? Generally, it is assumed that urbanization cannot be the driver of climate change. Urbanization is driven primarily by economic and political change. Urbanization in almost all low and middle income nations has been driven by investment patterns in the last few decades. Investment patterns have increased the proportion of production in industry and services. It has increased the proportion of the economically active population working in these industries and services. Looking from the production perspective, the increase in the use of fossil fuels in industries and services drive the growth in GHG emissions in low income and most lower middle income nations. This is related to urbanization in the extent to which production is within urban boundaries. For instance, the rapid growth in GHG emissions in cities such as Beijing and Shanghai is driven in large part by the very great expansion in manufacturing. Low income nations that have little or no economic growth may have little or no growth in GHGs in their urban areas, just as they generally have little or no increase in their urbanization levels. However, in case of low and middle income nations that become wealthier, the location of consumers and the changes in their consumption behavior become increasingly important contributors to GHG emissions. For example, in India, it can be assumed that it is generally urban areas with heavy industry that have the highest GHG emissions per person, but in particularly successful cities such as Delhi, Mumbai, Pune, and Bangalore, GHG emissions per capita may be increasingly driven by the consumption patterns of their high income groups. The high consumption and rapid growth in consumption, not population or rapid population growth, or urbanization are the real drivers of GHG emissions growth. If assessment of GHG emissions by the consumption and lifestyles of households were possible, it would be found that GHG emissions per person accounted for the very rich would be thousands of times greater than those of large sections of the poorest groups.
So students, let us sum up what we have learned from this module. It would be incorrect to suggest that an increase in population drives the growth in greenhouse gas emissions. It is the growth in the number of consumers and the greenhouse gas implications of their consumption patterns that are the issue. Looking from the consumption perspective, 20% of the world population with the highest consumption levels is likely to account for more than 80% of all human-induced greenhouse gas emissions. In order to reduce emissions globally, more attention should be directed to reducing greenhouse gas emissions of this group. Since national and local governments are allocated the responsibilities for addressing this, consideration should be given to the distribution among nations of this 20% of the world population. In order to achieve much needed rapid decrease in greenhouse gas emissions globally, it is essential to focus on rapidly changing the consumption patterns of present and future consumers with above fair share greenhouse gas emissions. The priority within energy policy is to support those living in energy poverty. Although this will increase greenhouse gas emissions, it can nonetheless be achieved at emissions per person far below the fair share level. Thus, it is the changes in affluence or of increasingly affluent individuals, households, and societies that are most important demographic causes of human induced greenhouse gases already present in the atmosphere and the most important drivers of their growth. From the consumption perspective, this is linked with urbanization only when an increasing proportion of consumption occurs in urban areas, which is only partly the case in high income nations and maybe in some middle income nations as well. In the context of adaptation to climate change, the key issue in low and middle income nations is to reduce the risks. That's all with this lecture. I hope you must have enjoyed it. Thank you.